Video, we're going to learn how to graph like the sine function and the cosine function. Okay, first of all, we have to recall the simple sine and cosine function. Notice that at 0, the value of cosine, it's 0. At pi over 2, it's 1. At pi, it's 0 again. At 3 pi over 2, it's -1. And at 2 pi, it's 0. Now, for the cosine function, the cosine value at 0, it's 1. The cosine value at pi over 2, it's 0. At pi, it's -1. At 3 pi over 2, it's 0. And at 2 pi, it's 1. Now, the period of both the sine and cosine function, it's 2 pi. Like, in other words, if we were to plug in numbers starting from 0 to 2 pi, we would get the full sine and cosine drawn out one time. So we will get its full range of values once, and it takes from 0 to 2 pi to do so. That means that the period, it's what? 2 pi. Now, okay, so now let's use that knowledge to graph something like sine of 2x, right? So the first step is this. We have to do the following. So the period equals 2 pi over b. And from this more generalized version of the sine function, the v value, like the v value is the coefficient of the x. In other words, the number in front of the x. So for our given problem, our b is equal to what? 2. So we just plug it into this formula here. 2 pi over 2 is equal to what? Pi. So in other words, the period of the function sine of 2x, it's what? Pi. So now what I'm going to do now is I'm going to take whatever the period was in step 1, I'm going to now divide it by 4. So since the p was equal to pi, I'm going to divide it by what? 4. Great. And the reason being, it's because if you remember, the regular sine function, f of x, sine of x, we have 4 important values, 1, 2, 3, 4. In other words, we have 4 x values that we denote on the actual graph of the sine function. This is why we have this here. It's going to be more clear as we progress. So don't worry about it for now if you didn't catch on. The most important thing so far is that you know that period p is equal to 2 pi over b. The b value comes from the coefficient in front of the x, so it's 2. So I plug it in and I get pi. And then whatever value for p that I got in the first step, I just now divide it by 4 to get the second steps, which in this case it will be what? Pi over 4. Now just for the third step, starting at 0, we're going to add pi over 4, but to be more precise, we're going to add p over 4, like to 0, and we continue until we get back to p. In this case, it's going to be pi for our problem. So let's see how that looks like. So starting at 0, I'm going to add pi over 4, and it gives us pi over 4. Then starting at pi over 4, I'm going to keep adding pi over 4. So I get 2 pi over 4. Don't simplify, now simplify at the end. And then from 2 pi over 4, I'm going to keep adding what? Pi over 4. So I get 3 pi over 4 until I get back the period, which is p. So at 3 pi over 4, I'm going to add another pi over 4, which gives us 4 pi over 4, which is just pi. Now, like simplifying this, we get pi over 4, comma 2 pi over 4, which is just pi over 2. And then we get 3 pi over 4. And then we get 4 pi over 4, which is just what? Pi. And then we get 4 pi over 4, which is, 1, 2, 3, 4. Where did I mess up at? Oh, so I actually found my error, and it's done because I listed it. So in other words, we starting at 0. We add pi over 4 to the previous number, so that I get 0 plus pi over 4, which is pi over 4. Then I take this pi over 4 and I add pi over 4 again, which gives me 2 pi over 4. Don't simplify now. Then I take the 2 pi over 4 and I add another pi over 4, which gives me 3 pi over 4. And finally, I take the 3 pi over 4 and I add pi over 4, which gives me 4 pi over 4, which is just pi. And notice that I got the period again. And in our problem, the period was pi. Okay, now we simplify, so we get 0 pi over 4. And then for this one, 2 pi over 4, it's pi halves. Then for 3 pi over 4, it's just 3 pi over 4, and then pi. And notice that if you did this correctly, we should have 5 values. 1, 2, 3, 4, and 5. So we did it correctly. Now for step 4, we take the values found in step 3 and we label the x-axis with those values. So 0, pi over 4, pi over 2, 3 pi over 4, and pi. And remembering that the sine graph looks like this, we're going to what? Do the same thing. So it starts here, goes to 1, 0, -1, and 0. So we're just what? Connecting them. So really, all, graphing these more complicated sine graphs, it's just a relabeling. So you're basically like relabeling the sine and cosine functions. So now let's do the cosine function without without a mistake. So here I have f of x equals cosine of 3x. And remember, the first step, recall that p is equal to 2 pi over b. And remembering the more generalized cosine function, the b, it's the coefficient in front of the x, in other words, the number. So here we have 3, so I'm going to plug it in. So it's 2 pi over 3. So our period for the given function, it's 2 pi over 3. Then for step 2, I'm going to take the period and I'm going to divide it by 4. So in other words, this divided by 4. Now a shortcut to this would just be, hey, since it's a fraction, you're dividing by 4, just take these two, and you're always going to multiply them if it's a fraction. So in other words, you get 2 pi over 12, and we could simplify that, which gives us pi over 6. But if you do not want to use a shortcut, or the shortcut doesn't make sense to you, recall that 2 pi over 3 divided by 4, this symbol here means division. So we're going to divide by it. So it's going to be 2 pi over 3 divided by 4. And I'm going to write it over 1. And the reason being, we cannot divide fractions directly. So we have to use our trusted friend KCF. In other words, keep, change, and flip. So I'm going to keep the first one. Then I'm going to change it to multiplication. Then I'm going to what? Flip it. And remember, for fractions, you multiply what? Straight across. Numerators are numerators, denominators are denominators. So we get 2 pi over 12. So we get pi over 6, the same thing. So just remember, if we have a fraction, then all we have to do here, we just multiply the numbers and be done with it. So, okay, fine. So now that step 2 is out the way, remember, starting at 0, we're going to add the pi 4th value over and over and over again to the previous number, and until we get our period, in this case 2 pi over 3. So now I start at 0, so I'm going to add pi over 6 to it, so I get pi over 6. Then at pi over 6, I'm going to add another pi over 6, which gives us 2 pi over 6. And then I'm going to add another pi over 6, which gives us 3 pi over 6. And then finally, I'm going to take the 3 pi over 6, and I'm going to add another pi over 6, which is going to give us what? 4 pi over 6. And then here's where I do the simplification. So I get 0, pi over 6, 2 pi over 6. 2 goes into 6 3 times, so that's pi over 3. Then for 3 pi over 6, 3 goes into 6 twice, so it's pi over 2. Then finally, we're going to get 2 pi over 3. And remember, if we did the third step correctly, we should have 5 numbers. 1, 2, 3, 4, 5. Cool. And this is what we're going to label our x-axis. So notice again, I label the 6 points, sorry, the 5 points in step 3. And I just draw again the regular cosine graph. The only difference is instead of calling it 0, pi over 2, pi, 3 pi over 2, and pi, I just, relabeled the points. So just think of this graphing, this more complicated cosine function. Think of it as just relabeling like the original cosine graph. But we have to recall that the general cosine and sine graphs have f of x, a sine parentheses bx plus c, comma, parentheses plus d, and etc. So far, we only handled sine and cosine functions of this form. Okay, now let's kick it up a notch. Okay, so now we're going to move on to graphing sine and cosine functions with a phase shift. And what that means is that instead of it just being 2x, we now have plus or minus something inside of the argument of the sine function. Okay, first of all, what the phase shift does, it's a horizontal shift. So it's going to move the sine graph to the left or the right, depending on this sign here. But first of all, before we begin talking about it, for now on, every time you have a sine function and it's more things going, if it's 2 things happening inside of it, what you're going to do is you're going to factor the coefficient of the x so that the coefficient is 1. So in this case, there's a 2. I'm going to factor out the 2. And the trick is, whatever this number is, you're going to divide it out by that number there. You're going to divide that number by the coefficient of the x. So in this case, I'm going to take 4 pi over 2 and going to divide out by 2 because that's a 2. And then we're going to get sine of 2 parentheses x, and simplifying here, 4 divided by 2, it's what? 2 pi. Great. So now our phase shift, remember, this is the B. Our phase shift, this is the phase shift. So our phase shift is C. And typically, some books denote the phase shift as phi, as a function phi. So I'm just going to write it as C, but your textbook may use that notation. And what that's saying is that, hey, the phase shift, oh, and we take the opposite of the sign here. So since it's positive, it's going to be what? Negative 2 pi. In other words, if it were if it were negative, if the sign here were negative, the phase shift would be what? The opposite, so it would be positive. But in this case, the sign in the middle, it's positive. Okay, so getting that out the way, okay, so how do we graph this? Guess what? We're going to have the same 3 steps as we're going to have the same steps as previously, plus 1 more step. And each time we add more complexity to the sine function, that just means we're going to have that many steps. But for now, it's the same steps as the previous problem, but we're going to have what? 1 more step. So for our first step, we're going to use the definition of the period of the sine function. It equals 2 pi over b. Using our factored form here, the b, it's 2, so it's going to be 2 pi over 2, which is just what? Pi. And then for step 2, I'm going to take the period and I'm going to divide it by 4. So it gives us what? Pi over 4. Then step 3 again, starting at 0, I'm going to start at 0. Then I'm going to add pi over 4 to each previous step to get the next number, which is, this would be pi over 4. I'm going to keep adding until I get pi. This is going to be 2 pi over 4. Don't simplify now. I like to simplify towards the end. So I get 3 pi over 4. Then I get 4 pi over 4 with plus pi. I took the 3 pi over 4 and I added pi over 4, which gave me what? Pi. Cool. So now what I could do now is I could simplify 0 pi over 4 pi over 2 3 pi over 4, and then we get what? Pi. Okay, notice we have the same 3 steps as previously. Now, this is going to be the phase shift step, step 4. All we do now is that we take the numbers. We take the numbers in step 3 and add the phase shift to each of them to get our new points on the x-axis, or our new tick marks on the x-axis. All right, cool. So let's do that. So here, what I did was from above, our phase shift was negative 2 pi. So I'm taking the numbers found in step 3 and I'm subtracting negative 2 pi from it. And I'm actually adding negative 2 pi, but it's subtraction. Okay, whatever. So negative 2 pi. Then here it's going to be, notice that in order to do this is I'm going to multiply this by 4. So I'm going to get 8 pi over 4, and we're going to reduce later. Going to do the same thing here. That's 2. So I'm going to multiply this by 4 and write it under 2. So I'm going to get pi minus 4 pi. Then again, this is a 4. So I'm going to multiply this by 2. So I get minus 8 pi over 4. And then for this one, I could subtract as is. It gives me negative pi. And then just doing a bit of cleanup now. This is, I guess, the hard part. It's the arithmetic, I guess, adding, subtracting fractions. It's kind of annoying. 765. So I get negative 5 pi over 4 for this one. And I get negative pi. So guess what? These would be the new points that we're going to graph. So let's graph it now. I should maybe stretch it out more here. Okay, so it's going to be negative 2 pi, negative 7 pi over 4, negative 3 pi over 2, negative 5 pi over 4, and negative pi. So now, again, since we're graphing the sine function, it's going to be here. We're just relabeling it. So just graph the normal sine function here, here, and here. So this gives us one full period. Then if you want to extend it, then you could extend it. But that gives us one full period. Now, okay, now let's do the cosine function of this. So again, the first step should always be to factor the inside, the argument, the inside of the cosine function. So remember, I want the coefficient of the x to be 1. So I'm going to factor out the 4. But remember, to make this simple, whatever number this is here, just divide it by the number in the front, in this case 4. So our step 1, remember, period equals 2 pi over b. In this case, our b, it's 4, the number in front of the x. So it's 2 pi over 4, which is pi over 2. Step 2, we're going to take the period and divide it by 4. And if you paid attention to the shortcut earlier, hey, if this is a fraction, in other words, pi over 2, that's a fraction divided by a number, all you have to do is just take this and just multiply them. So we're going to get pi over 8. Okay, step 3, we're going to start at 0, but each time we're going to add pi over 8 to the previous step. So 0, 0 plus pi over 8, which is just pi over 8. Pi over 8 plus pi over 8, which is 2 pi over 8. Then we're going to get 2 pi over 8 plus pi over 8, which is 3 pi over 8. And then we're going, finally, for the last one, pi over 8 plus pi over 8 gives us 4 pi over 8. And if you were to reduce this, it will give us pi over 2. And notice that we got back the period. And if we do this correctly, we should have 1, 2, 3, 4, and 5. 5 numbers. So let's go ahead and simplify. Pi over 8, pi over 2 divided by 8. That's pi over 4. 3 pi over 8. And we got, hold on, did I mess up here? No, I'm just missing the what? Pi over 2. Now, because we have a phase shift, the phase shift, it's this number in the fully factored form. That's why initially I say, hey, always factored, because now our phase shift, remember some books use the phi. It's just going to be the opposite of this number here. So it's negative pi over 4 here. So it's actually what? Pi over 4. And since it's pi over 4, we're going to move horizontally. Every point moves pi over 4 units horizontally. And what that means is we're going to take the points, or sorry, the numbers in step 3, and we're going to add the phase shift to it. So in this case, step 4, we're going to add what? Pi over 4. So doing it here, it's going to be 0 plus pi over 4, 0 plus what? Pi over 4, pi over 4 plus what? Pi over 4. And then we're going to take 3 pi over 8 plus pi over 4. Then we're going to take pi over 2 plus what? Pi over 4. So then now, simplifying pi over 4. Notice here it's an 8 and a 4. In order to add them, I need to multiply top and bottom by 2. So I get 3 pi over 8. Here they have the same denominator, so I just add them across. 2 pi over 4. Here I need to, it's an 8 and a 4, so I need to make this denominator 8. So I multiply top and bottom by a 2. So I get 2 pi over 8. And then here I'm going to multiply this by a 2. So I get 3 pi over what? 4. And then checking to see if I did it correctly. Yes. Now I'm just going to simplify. And guess what? These are the tick marks on the x-axis. The x values that we're going to use are labeling. So we could, when we're done, we just have to put the points in. Pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, and what? 3 pi over 4. And remembering that the cosine function, it starts at 1 when it's 0. So we just shifted it over. Remember, it's a relabeling. So we just draw the typical sketch outline of the cosine function, and we connect the points. Easy peasy. Cool. So this would be the graph of f of x equals cosine of this. I'm not going to say this whole complicated thing. So notice that essentially for all these problems, we're going to be doing the same steps over and over and over again. So now let's do something a bit more complicated. Let's just go ahead and just do the whole generalized version now. So going back to the generalized function, the generalized sine function, notice that we talked about B and C, but we never talked about A and D. So what A is the amplitude, and to best describe that, let's again draw the simple sine function. And notice here that the highest value it's 1, and the smallest value between -1. So it goes through the range of the values of the sine function are trapped between -1 and 1. Cool. So what the amplitude does, whatever A is, it changes the max value and it changes the min value by whatever the A is. Now what the D does, just like when we graph, when we graph functions in algebra, it moves every point up or down vertically by whatever the value of D is. It does the same thing here. Okay, and remember this thing here, it's both the period and the what? Phase shift, and we're going to apply what we did earlier, But now all we're going to do is just change the y values on the graph. And if needed, we're just going to move it what? Up or down. So here I have this problem. Okay. Hey, just because we have everything now, it doesn't make it more complicated. If anything, we're going to do the same steps. So step one, well, before we start step one, remember we would like to factor the inside argument of the sine function. So 4x and whatever that is, I'm going to divide it by 4. Oh, and then because 2 goes into 4, it's just going to be what? Pi halves. Great. Plus 1. Okay, so having that, now we start our first step. And recall our first step was to find the period. Period, it's 2 pi over b. And remember, it comes from the coefficient in front of the x, which is 4. So 2 pi over 4, which is what? Pi over 2. So now for the second step, I'm going to take the period and I'm going to divide it by 4. So pi over 2 divided by 4. Recall the shortcut. If it's just a number, it's just, or this case, we just what? Multiply it. So it's going to be pi over what? 8. Oh, and just to point something out, let's say hypothetically, it was pi over 2 divided by, let's say 4/3, then our shortcut would not apply. I'm sorry if I did not make this clear earlier. In this case, you would just do it the what? The long way, using keep, change, and what? Flip. But in this case, it's just no fraction at the bottom divided by no fraction, integer to be more precise. We just multiply it. So we get pi over 8. All right, cool. And then recall that our step 3 is starting at 0. We keep adding what? Pi over 8 to the previous step until we get back our period. In this case, it's what? Pi over 2. Pi over 8 plus pi over 8, 2 pi over 8. And then, blah, 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 blah. We continue. Let me teach you a trick. So, starting at, so write 0, okay, then pi over 8. Then for the next one, just multiply this by 2. So it's going to be what? 2 pi over 8. Then go back to this guy here and multiply it by what? By 3. So it's going to be what? Pi over 8. Then take this guy and you multiply it by what? 4 to get the next one. So it's going to be 4 pi over 8. And then notice we have 5 points. And then simplifying pi. If you don't like this new way of doing it, just do the old previous way that we've seen. Get pi over 4, 3 pi over 8, and what? Pi over 2. Now, recalling that we have it fully factored, our phase shift, it's always the opposite of that number. So our phase shift is going to be what? Pi over 2. And just to get it out the way, our amplitude, it's the number in front of the sign. Our amplitude, it's 2. And our vertical shift, it's a positive 1. So vertical shift equals 1. So we're going to move everything. But first, just getting that out the way because we're going to miss the stuff. I have to scroll down a bit. These problems are long. But the good thing is once you practice this method, you can literally graph sine and cosine functions in under 2 minutes. No matter how complex it is, you practice a bit and you can literally do it in under 2 minutes. Try it, practice. So now, recalling that our fourth step, we take the numbers found in step 3 and we add our phase shift. Remember, since here it was negative, we're just going to add it. So we're going to change the sign to this positive. Remember, the phase shift comes from the fully factored version. And to be precise, VC, whatever book you have, it's essentially this value divided by the b. So it's going to be this value here divided by the b. But I don't like doing it there. I just be like, hey, just factor it. So that right off the bat, you could just spot it. You could just get it. Cool. So anyways, our phase shift is pi over 2. So remember, starting from the values found in step 3, we're going to add it. So it's going to be 0 plus pi over 2, pi over 8 plus pi over 2, pi over 4 plus what? Pi over 2, 3 pi over 8 plus pi over 2, and pi over 2 plus what? Pi over 2. So now let's simplify. Remember, this is an 8 and that's a 2, so I need to multiply this top and bottom by 4. So pi plus 4 pi, it's going to give us what? 5 pi. Then for the next one, that's a 4 and that's a 2. I'm going to write 4 at the bottom. So now here, what I'm going to do is it's going to be what? It's going to be, oh, I'll multiply it by 2. So it's going to be 3 pi over 4. And then for this one, I'm going to multiply by 4. So I get 3 pi plus 4 pi over 8, which is 5, 6, which is going to be what? 7 pi over 8. And then for this one, it's the same. So it's just going to be what? 2 pi, which is just going to be what? Pi. So that's what we have so far. Good. So these are the points which I'm going to draw now on my x-axis. Let's make it a bit neater. Now, here, since we're graphing the sine function, remember for the first step, it's just these 5 points here. We just draw the typical basic sine function. Remember, it's just a relabeling. That's how you could think of it. So we just connect it. Boom. But, it would be wrong if we put 1 and -1. Why? Because our amplitude is 2. So instead of writing -1 and 1, whatever the 2 is, that's what's going to change the max and min value. So it's going to be 2, and you take the negative version, which is what? -2. Then we would be almost done if we did not. So so far we have that. But since we have a vertical shift, remember this one here, we have to move every point upwards, in this case by 1 because it is positive. So in other words, this is going to, let me write a 1 there, and let me write a -1 here. So in other words, this value here, it's at 0, so it's going to move vertically by 1. This value, it's at 2, so it's going to move to what? 3. This value, it's at 0, so it's going to move to 1. This value is at -2, so it's going to move to -1. And this value, it's at 0, so it's going to move 1. But guess what? All we do now is we just connect the points. And then we essentially graph the function that we wanted to graph. And we could do this for both the cosine and the sine function. The video is getting a bit long, but it's essentially the same steps for the cosine and sine function. Again, it's the same steps. So now, no matter what type of sine and cosine function I give you, following the steps in the video, you could literally graph them all. And to top it off, once you practice this method over and over again, you could essentially graph these in under 2 minutes. I kid you not. So if you want me to graph more problems of sine and cosine functions, leave a comment in the video, and I'll gladly work out some more problems. But essentially, it is the same. But if you need more help, don't be scared to reach out. Like, I'm here to help you guys. And as always, like, share, and subscribe. And thank you for watching the video.